With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello. So question is saying that which of the following reaction, right? So which of the following reaction will not form racemic mixture as a product, right? So let's start solving this question. And for racemic mixture, we know that the product must be our chiral, right? So that means our product must be a chiral for showing the racemic mixture, right? So that means if the compound or the product is not chiral, that means it will not show racemic mixture. This is the basic concept, right? So let's see the reaction, right? So the first reaction is like this, right? This is CH3 and this is CH2, right? And this is COCH3, right? This is COCH3, right? So when we react this compound, carbonyl compound, with HCN, right? With HCN, right? So we'll get here a cyanohydrin product like this, right? So here, because you can see this negative charge here, right? So this negative charge attack on this electrophilic carbon, right? So since this is electrophilic carbon, right? This is electrophilic carbon, right? And due to the electronegativity of oxygen, right? So this carbon or this cyanide is attack here, right? So the product will be like this, right? So the product will be like this: the CH3, CH2, CO negative, right? CH3, that is CH3, CH2, CHO negative. Here it is CN, right? Here it is CN, here it is CH3, right? So if we add H plus here in it, so that means this H positive, right? So this is H positive and this is H positive, right? So now this will abstract this, so the product will be like this, right? So I can write this, so it will be like this: CH3, CH2, right? And COH, CH3, right? And it is CN, right? So now you can see here this carbon becomes chiral, right? So now you can see here this carbon becomes chiral, right? So this carbon becomes chiral due to presence of different 4 groups, right? These are the different 4 groups, right? These are the different 4 groups, right? So due to this different groups, this carbon becomes chiral. That means it can show the racemic mix. That means it can show it may be D or it may be L, right? So that means from this since this is a carbonyl, so here the cyanide can attack through up and cyanide can attack through below, right? That means there is a formation of possibility of D or L form. That means here is a possibility of racemic mixture, right? Also, so that means here this reaction will show a racemic mixture, right? So will show a racemic mixture as a product, right? So that means we have to find such a reaction that will not form racemic mixture, right? And for not forming the racemic mixture, the carbon must be, or you can say the central atom must be achiral, right? So must be achiral. That means there should be no 4 different groups, right? So I can say if I talk about B, right? So that is CH3, right? So this is CH3 whole twice, right? So I can say this is CH3 whole twice, or you can say that is CH, right? And this is CH double bond CH2, CH double bond CH2, right? So if I react with chlorine, right? So that is HCl, right? Here, so here you can see that this is alkene, electron rich species, so it will attack on this hydrogen as positive ions, right? So this is positive and this is negative, right? So then there's a formation of carbocation, right? So this is carbon is 2 methyl group here, right? So this is 2 methyl group and 1 is hydrogen, right? And here you can see this, there's a formation of carbocation, right? So there is a formation of secondary carbocation and this becomes CH3, right? So now you can see here this is secondary carbocation, and we know that there's a speciality of the carbocation is that if there is a possibility of rearrangement, then there is a rearrangement will occur, right? So now you can see here there is a 1,2 hydride shift, right? So there is a 1,2 hydride shift, 1,2 hydride shift will take place here, right? So due to the formation, because there after 1,2 hydride shift there's a tertiary carbocation formed, right? So which is more stable as compared to secondary carbocation, right? So since you can see here this is secondary carbocation, right? So now the carbocation will becomes like this. This is tertiary carbocation, right? This is CH3, here this is CH3. Now this becomes CH2 and this is CH2, right? And this becomes positively charged, right? Now this is become tertiary carbocation, right? So now you can see here if we attack over here, we have a Cl negative also, right? So we have a Cl negative also. So this Cl negative attack on this carbocation, right? So attack on this carbocation, right? So I can write like this. So Cl negative attack on like this. So it will form the product like this, right? So it will form the product like this. That is CH3 here, CH3 here, right? And here Cl, right? And here you can see this CH2, CH3, right? Now this carbon becomes achiral, right? Due to the presence of same groups, right? These two CH3 group, right? These two CH3 group is same. That means this carbon is not chiral. That means I can say this carbon is achiral, right? So this carbon is achiral, right? That means it will not form racemic mixture, right? That means it will not form racemic mixture. While for the showing the racemic mixture, carbon, or you can say the central atom, must be chiral, right? So according to this, our answer should be B, right? So let's check the another reaction option. That is another reaction that is taking place here. You can see here the reaction is like this. So the reaction, if I talk about the reaction C here, in the reactant is like this, right? This is our cyclohexane ring, and this is double bond here, and this is methyl group, and this is methyl group, right? So when we react with this, when we react this reagent with HCl, right? So when we react this reagent with HCl, right? So then there is a formation of carboctane also, right? You can see here, and tertiary carboctane will form, right? So and tertiary carboctane will form here, right? So you can see here, this is tertiary carboctane will form, and here hydrogen is attached here, right? So hydrogen will be attached here, right? So now you can see here Cl, which is Cl here, so it will attack on this carboctane, right? So I can write here like this. So Cl will attack on here, so it will form a compound like this, right? So this is our cyclohexane ring, and this is methyl group, and here you can see this is chlorine, right? So now you can see this, there are 4 different groups, right? So this is methyl group, right? So this is methyl group, another different group, and here this becomes another group, right? And here this becomes another group, right? So now you can see, and this is chlorine, right? That means this particular carbon becomes chiral, right? So this particular carbon becomes chiral. That means it will form racemic mixture, right? So it will form racemic mixture, right? So if I talking about the reaction D, right? So if I talking about the reaction D, here you can say there is a 1 2 3 4, that is butene, right? So if this is butene, right? So this is butene. So if I talking about the reaction D, that is CH3 CH2 CH double bond CH2, right? CH double bond CH2, when it is reacted with HBr, right? So when it is reacted with HBr, so you can see here there is a possibility of carboctane, right? So you can see here then CH3 CH2, right? And here it becomes CH positive, right? And here it is CH2, right? Here it is CH2, right? So now you can not CH2, it is CH3, right? So it is CH3, right? So now you can see here, this is the reaction in which HBr is reacting, right? So now this reaction is taking place. Now here bromine will attack on this carboctane, right? So here since this is a secondary carboctane, right? So rearrangement is possible if this hydrogen is moved from here to here. So then there will be a secondary carboctane. That means only in this particular compound there will be only secondary carboctane, right? So there is no possibility of becoming the tertiary carboctane. That means bromine will attack on this carboctane here, and which comes from this HBr, right? So the compound will be formed like this, that is CH3 CH2, right? And here it is H, right? So this is H, and here this is Br, and this is CH3, right? So now you can see here these groups are different group, right? So these are different group, right? These are different group, right? So now you can see here that means this carbon becomes chiral, right? So this carbon becomes chiral, and due to this chiral it will show a racemic mixture, right? So it will show a racemic mixture. That means this reaction will show a racemic mixture, right? So now, but in the question it is asked that which of the following reaction is not from the racemic mixture, right? So you can see here in above 2 reaction, A, B and D reaction, A, C and D, right? So not B, A, C and D reaction will show the racemic mixture, that right? While the reaction B is showing will not form racemic mixture because presence of achiral carbon, right? There is a, you can see here the carbon is achiral, right? So in this way I can say that option B will be the correct answer, right? Option B will be the correct answer, in which the racemic mixture will not form as a product, right? So I can say that option A, C and D will be the wrong answer, right? So hope this answered your question. So thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.